In this video, we're going to talk about linear equations in two variables. So a linear equation in two variables. One form is ax plus by is equal to c, which is called standard form of the equation, where a, b, and c are real numbers, and a and b both can't be equal to 0. Examples: 3x minus 2y is equal to 5, x equal to negative 4, and y equals 2x plus 1. Those are all examples of linear equations in two variables. Okay, before we go any further with equations, I want to review very quickly about slope. So the slope of a line is how much a line increases or decreases. We know that the slope is m. Usually the terminology students give me is rise over run. Well, the rise is a change in the y-axis. The run is a change in x-axis, which that means exactly the same as delta y divided by delta x. And we know the slope formula then is y2 minus y1 divided by x2 minus x1. All right, so let's calculate the slope of the line passing through the given points. We'll do these quickly. Okay. So we know the slope, again, is equal to y2 minus y1 over x2 minus x1. Now I'll label x1, y1, x2, y2. So the slope is 4 minus 4 divided by 1 minus a negative 2. Well, 4 minus 4 is 0. 1 minus a negative 2 is 3. My slope is 0. Now, what I would like to do is, what type of line has a slope of 0? Well, I'm going to graph very quickly these 2 points. Okay, so negative 2 and 4, that's going to go about here. And 1 and negative 4. Now, notice what line is being formed here. Okay? That is a horizontal line. So in other words, a horizontal line has a slope of 0. Okay, so we'll fill that in later on in this video. But no, a horizontal line has a slope of 0. Okay, let's do the other example of the slope here. So again, I can write this as a slope form. M equal to y2 minus y1 over x2 minus x1. Again, I can label x1, y1, x2, y2. So this is going to be 2 minus 1 divided by 3 minus 3. Well, that's 1 over 0. So there is no slope, or if you would prefer, undefined slope. Well, what type of line has a no slope or an undefined slope? Well, again, similarly to what I did a minute ago, I can graph very quickly. So what do I have? 3, 1 and 3, 2. Well, if I connect those, okay, we know that we have a vertical line. So a vertical line has no or undefined slope. Okay. So now I can fill this out on the bottom of this page then. The slope of a horizontal line, well, thanks to the first example we did, is 0. Okay. The slope of a vertical line is undefined or no slope. So again, there is the difference between a slope of a horizontal line and the slope of a vertical line. One is 0, the other one is undefined or no slope. Now, so what I would like to do for the rest of this video is to graph equations using the slope of the y-intercept. Now, if you recall, slope-intercept form is y equal to mx plus b, where m is a slope and b is a y-intercept. And remember, I can write the y-intercept as 0, b. All right, so I want to graph the line y equal to negative 2/3 x minus 2 using the slope of the y-intercept. First of all, identify both parts. The slope is negative 2/3. Y-intercept is negative 2, but I'm going to write that as the ordered pair 0, negative 2. Now, the slope being negative 2/3. Keep in mind, if it's negative 2 over negative 3, well, the two directions I'm going to go would be down, because that's a change in y on the top, and to the right, because that's positive. But you can also write the slope as 2 divided by negative 3. If you wrote it like this, that would mean I would go up and to the left 3. But keep in mind, I'm not going to put a negative on the top and a negative on the bottom, because if I did that, it would end up being positive, because a negative divided by a negative is a positive. Okay, let's graph. Again, hopefully you'll be able to graph a little bit better than what mine is going to look like, but you can at least get a sketch for this. So, first off, let's graph the y-intercept at 0, negative 2. Now, one of the slopes I came up with was to go down 2 and to the right 3, so I'm going to do that. But the other one, I'm going to go up 2 and to the left 3. And you can tell these three blue lines, they do form a line. Okay. So this is a nice quick way to graph a line if it's in slope-intercept form, if you understand the slope and the y-intercept. Okay, one other example I would like to do is to graph this equation using the slope of the y-intercept. Notice this is not in slope-intercept form. Remember, slope-intercept form, y equals mx plus b. So I need to solve this equation for y. So first off, I will subtract 4x. Now I will put the x term first. And now I need to divide everything by 2. Well, negative 4 divided by 2 is negative 2. And 1 divided by 2, I'm going to leave as 1/2. So again, now that this is in slope-intercept form, it's easy to identify the slope. Now remember, that's going to be negative 2 over 1. I'm going to need two different directions of the slope. The y-intercept is 1, 0, and 1/2. Now, if it's negative 2 and 1, well, I can go, down into the right, or if I rewrote it as 2 over negative 1, that means I could go up and to the left. So I will use both directions to graph this line to show you that both of those definitions of the slope will get me to the same line. So let's graph. All right, so in a different color, first of all, you want to graph the y-intercept first. Now, I would like to go down 2, so that's 1 and 2, to the right 1. Okay. Or I can go up 2, 1, 2, and to the left 1, and I would be here. Again, you can tell all three of these points, when connected, is going to be a line. Okay. So there is my equation of the line in slope-intercept form.